So today's lesson we're going to be talking about vertical asymptotes, holes, and actually x-intercepts as well. So first thing I want you to notice on all these graphs I've drawn, you won't be drawing graphs yet, but you do need to know what a vertical asymptote looks like on the graph. That's this dotted vertical line right here. So this first one is at 4, this next one's at -2, and this one we have two of them at +1 and -2. This one we've got one at +2 or 3, sorry, and then this next one we've got one at -2. What you'll notice is all of those have a 0, so 3, if you look at the denominator, is the 0 of this factor right here. -2 is the 0 of this factor right here. If I go back to this one, there's two of them. That's the 0 of both of these factors, 1 and -2. And then if I go back to the original, the 0 of x minus 4 is 4, 0 of x plus 2 is -2. The reason that happens is because vertical asymptotes are defined as values that, or numbers, x values, that create an undefined equation. So it's where the denominator is actually equal to 0. So, but what you'll notice is that some of them don't have, so we didn't include some of our denominators, and that's because there's something special about those ones. If you look at the top and bottom, you'll notice that those ones are common factors. And if we look at +2, for instance, that's where you have what's called a hole. So this is what a hole looks like. So common factors give you holes, but anything else left on the denominator give you vertical asymptotes. So that's why this problem, there were two vertical asymptotes, because neither one of those had common factors. Last thing we're going to talk about are x-intercepts. So like this problem has one x-intercept at -1. If you notice, that is the 0 of the numerator. So in this one, we should have an x-intercept at +4, and we in fact do. If I go back to this one, notice how there's no x on it. That means there should be no x-intercept, and you'll notice there are no x-intercepts in this graph. Likewise, no x-intercept on this one, since there are no x's. But on this problem, there's an x-intercept at 3, because that's the 0 of the numerator. The reason that happens is because x-intercepts are always defined as the x values where y is equal to 0. When you have a fraction, the only way you can get y to be 0 or to equal 0 is if the numerator is 0. You can have any number you want on the denominator, but if 0 is the numerator, then you can find your x-intercept. So that was just a brief little introduction into just the general idea. So soon we'll go ahead and talk about how to do it if things aren't factored out for us.